In this section, we want to talk about box plots, also known as box and whisker plots. The box plot is a graphical display of the 5-number summary for a data set. And in so doing, it kind of helps us be able to read that data set from very simple numbers. Now, a reminder what the 5-number summary is. The 5-number summary we learned a couple pages ago. It's the minimum, which is the lowest value, Q1, which is the 25th percentile, right, the first quartile, the median, which is the 50th percentile or second quartile, and Q3, which is the 75th percentile, and the max, which is the highest value. In so doing, in showing this picture, we can see the shape, the center, and the range, right? The center, the spread, and the range just by looking at it. And we can also kind of determine the shape, which is really nice. Now the center will be the median, and the median is the center line of the box. So if you look down here, this line right here in the middle of the box, that's the median. In this particular case, because this is our prescription data set from just a page ago, we know that the median was 670.5. So the value for this is 670.5. All right, that's the center. Now the spread is from Q1 to Q3. Q1 to Q3 is the box itself, because this edge of the box is Q1 and this edge of the box is Q3. Oops, my Q1 looks weird there. There we go. Q1 to Q3. All right, Q1 is 583 for this particular data set, and Q3 was 826.5. It's the 75th percentile. All right, so that tells us the spread. We can see how spread out this box is. And we also know the range because the minimum is the lowest value over here. Sometimes it's a whisker, sometimes it's a dot. In this case, it's the dot itself here. And the max is over here. And again, sometimes it's a whisker, sometimes it's a dot. In this case, it's a dot. Right? So keep in mind that this graph really is sharing a lot of information. We can see the range, we can see the spread, we can see the center. So we're seeing a lot of things. And we can also see outliers because outliers are the dots. Now keep in mind though, as far as we are concerned, the outliers are part of the whiskers, and that'll be for shape purposes. So when we're trying to determine the shape, which will happen in a page or two, that'll make more sense. Okay, so over here we wanted to label the 5-number summary on the graph, which we did. We didn't put in all the values. This value was 162 and this value was 1564 over here. Okay, now how does this dot plot show there are outliers? We said there were outliers. We found them in the previous page, right, the previous example. So we know that the outlier is 162 and another outlier is 1564. The box plot shows the outliers by putting dots for them. The whiskers do not extend to outliers. Now, you might think the whiskers go to the fences, but that's not actually true. Where the whiskers go to is the values that are inside the fences. So just for your own interest, this was an outlier, right? So 1564 was. So the fence was 1191, but that's not where that whisker's going. Where the whisker's going is to this number, 1159, right? So this particular number is the biggest number that's still inside the fence. So that's where that's going. Similarly, on the low side, this is 162, which is that outlier right there. So the whisker is going to the next number that's still within the fence, right? Still inside 217. So that whisker is not going to 217. It's not going to the fence. It's going to 294. So right here, and if you can see it, that's not 217. That's not close to the 200 line. That's going to 294. And I made that into a little note for y'all. So the whiskers go to the data values that are inside those fences, right? Which in this case was 294 and 1159. They do not go to the fences themselves, unless the fences are part of the data set. Now, how does the box plot show the shape of the distribution? Well, what shape was it? We never actually answered that. So if we look here, the mean was 712.75 and the median was 670. The mean is greater than the median, so it's skewed right. Now, how can we tell it from the box and whisker plot? Well, you can see that it's skewed right because the box is bigger, significantly bigger, on the right side than on the left side. And the whisker, which includes the dot, this is where that outlier dot is included, this is the whisker, right? So the whisker is the whole thing, if you want to think of it that way. And so therefore, this is longer on this side than it does on this side. So the box is larger on the right and the whisker, quote unquote, is larger on the right. The whisker including the dot, right? So that's what we write right here. All right, so I wrote that up. So you can tell it's skewed right because the right side of the box is bigger than the left, and the right whisker slash dot combo, right? The whisker and dot together are larger, right? And since they are larger, that means that it's skewed right. So now that leads us into the next page, which are some guidelines for how we can use box plots to judge the shape of a distribution. So if you want to think of a distribution as skewed right, how will that manifest in a box plot? It's also known as positively skewed, right? And the reason for that is that it's larger on the positive side, right, which is the larger side. Now they can draw box plots horizontally. They can also draw them vertically, but it still works the same way. This is still skewed right or skewed positively, right? It's longer whisker on the right or a longer box on the right, or sometimes both. Actually, the one that we just looked at was larger on both things. Both the box was bigger on the right and the whisker was bigger on the right. Now, if they're symmetric, that'll mean that everything's approximately equal, right? So symmetric will mean that the whiskers are basically the same and the boxes are basically the same, more or less, right? Now remember, we don't know what kind of shape that is. There are a lot of different symmetric graphs, uniform, bell-shaped, all sorts of things. So we don't know the shape of it, but we do know that it is symmetric, right? That it's even on both sides. But we don't know whether it's bell-shaped. And then there's skewed left. Skewed left would be a larger whisker on the left or a larger box on the left or both, right? So that's also known as negatively skewed because you're larger on the negative side of the number line, right? Towards the negative side of the number line. Now, there are occasionally times where the whisker and the box are in conflict. And which way it's skewed, you kind of have to make a judgment call about which is the more drastic difference that you're seeing. Usually that's the whisker, but not always. So if the whisker is just way longer on one side than the other, even if the boxes are reversed but they're pretty close, you would go with the whisker, right? But this is a judgment call that you're going to have to make based on the picture. And maybe that would be a time to go look at the mean and the median and maybe make a histogram. There are other graphs available to you at that point. And then for the purposes of determining shape, remember, this is very important. The outlier dot is part of the whisker as far as you are concerned, right? The outlier dot is an outlier, but it's part of the data set. And so you have to think of it as being there when you look at your box and whisker plot to think about whether it's skewed left or skewed right. Always mentally include those dots as part of the whisker's length.